Hey there, so today we're going to look at a problem where we are going to find the extreme values of a function. And what that means is we are going to look for the mins and maxes. Alright, so for this problem, we are given the function of f of x equals 1 over x plus the natural log of x. And in this problem, our domain is from 0.5 to 4. So our first step to finding the mins and the maxes is finding the derivative of our function. So f prime of x equals negative x, negative square, plus 1 over x. And so what I did here is in the original function, I changed 1 over x to x to the negative 1 to find the derivative, which I got negative x to negative square. And the derivative of the natural log of x is simply 1 over x. And so we are going to simplify the derivative further. And by that I mean move this negative power to the bottom of a fraction. So negative 1 over x squared plus 1 over x. And right away here we're going to multiply this second fraction, the top and the bottom, by x to get common denominators. And so we are going to simplify our derivative one last time. So f prime of x equals negative 1 plus x over x squared. And that is our step 1, finding the derivative of our function. Alright, so for step 2, what we want to do is we want to find the derivative when it is equal to 0. So step 2, I'm just going to rewrite our derivative up here, negative 1 plus x over x squared equals 0. And what we want to do here is we want to solve for x. So on both sides, we are going to multiply it by x squared. That way on the left side we get negative 1 plus x, and on the right we get 0. And we're going to keep solving for x by adding 1 to both sides. So that in the end we get x plus 1. And what this means here is that there is a min or a max at this point, and that is what we need to find out. Now the second part to the second step would be to find where the derivative is undefined. And for our problem here, the derivative is undefined at x equals 0, because we would get a 0 in the denominator. But because our domain is from 0.5 to 4, we don't need to worry about that 0, and so we're just going to focus on x equals 1. Alright, so for our third step, we need to find out if x equals 1 is a min or a max. And so we're going to start that out by creating a t-chart for our x's and y's. And what we're going to do is we're going to plug our endpoints of 0.5 and 4 and x equals 1 into our original function. Right up there. So, when we plug in x equals 0.5, we get about 1.3, 1. And when we plug in x equals 1, we get 1 for y. And when we plug in x equals 4, we get 1.64 for our y. Alright, and so what this tells us here is that at x equals 1, y equals 1. And that is our smallest y value that we got out of the 3, which means x equals 1 is a min. And when we plugged in x equals 4, we got the largest y value, which means x equals 4 is a max. And because 0.5 is in between our min and our max, 0.5 is our relative max. Alright, there you have it, the extreme values of a function. We're just going to write that out a little better. So, you have a max at x equals 4, a min at x equals 1, and a relative max at x equals 0.5. Alright, there you are, the extreme values of a function.